Day 3 on vectors, and so we have a little bit of a warm-up right up here, and today we're going to take a look, we'll review again at how to find the angle between two vectors. Well, to find the angle between two vectors is just our formula. The cosine of theta is equal to the dot product of our two vectors of v dot w divided by their individual magnitudes. Right there. And that's a little formula for this. So in order to calculate this, the first thing we're going to do is, of course, we're going to take the dot product, which is going to be 3 times negative 1. So that's going to give us negative 3 plus is 2 times negative 3, which is negative 6. If we divide by their magnitude, remember the magnitude is just the square root, like the magnitude of v would be the square root of 3 squared plus 2 squared. So that's going to give us the square root of, what's that? 9 plus 4, so that's going to be 13 times the magnitude of w, which is going to be this 1 times 9, which is just, it'd be 1 plus 9, so it'll be square root of 10. And that gives us a negative 9 over the square root of 130. If we take the inverse cosine of that negative 9 over root of 130, we should get 142.125 degrees. Of course, we're going to put our answers in degrees here. The next one we want to take a look at, we want to find the value of k. That'll make these two vectors parallel and perpendicular. So let's deal with parallel first. Now for parallel, I just think of slope. Remember we talked about we can think of these two vectors as being like a slope. So for example, this vector right here would be a slope of negative 2 over 4. This vector here would have a slope of k over 7. Well, if they're parallel, that would mean that their slopes would have to be the same. I could just cross multiply to solve this. It gives me negative 14 equals 4k. Therefore, k is equal to negative 14 over 4, or negative 7 halves. That's for parallel. Now for perpendicular, I could, again, use slope, but slope is only really good if we're dealing with single variables, or two dimensions. One way to get perpendicular, we want to use that dot product. So if I dot these together, these two vectors together, we should get 0. And of course that's going to give us 28 minus 2k is going to be 0. And of course k is going to be 14 right there. Pause if you need to take another step. Now we could do parallel lines another way. Find out the two parallel lines. We're going to talk a little bit about that later on. That's part of today's lesson. So let's go and get into today's lesson. How to write how to write a vector in linear form. We can write the equation of a line in many different ways using vectors. So let's say we have the following points, 2, 3, and negative 3, 5. We can write the following line as, in terms of a line, ym equals, my slope is negative 2/5. So my equation of my line would be y minus 3 equals negative 2/5 x minus 2. That would be our equation of a line from Algebra 1. Now let's say the line initially starts at the point 2, 3 and terminates at negative 3, 5. Now we have a vector because we have a starting and a final point. How can we write the equation of this line? This is called the vector equation of a line. And it's super easy to do. First, we find the slope. This is what we call the direction vector. This is the slope of our line. And this is just that component form that we talked about last week. So remember, to get the component form, to get our direction vector, or the component form, we are going to take where we ended up at, the terminal point, where we ended, minus where we started, the initial point. So, ready? We terminated at the point negative 3, 5, minus the initial, which was this 2, 3. And if I simplify that, this is negative 3 minus 2, so we get negative 5. 5 minus 3, 2, and there is our direction vector. Now notice, like slope, remember this point right here, this is my change in x, and this 2 is my change in y. And we see the same thing in our slope, change in x over change in y, so it's not really any different. we can write the equation in slope-intercept form. So that's like this y equals mx plus b. And remember y, this is now really kind of y is going to be my function, but we're going to write a function instead of y equals xy equals my slope. Well, my slope is my change in x, change in y. My x right here, this is just my messed up there. Sorry about that. Let me go back and refix this one, okay? So anyways, I do apologize for that. To get the slope, it's going to be in this form right here. Sorry. Slope-intercept form for vectors is written in the form xy equals x1, y1, just like our b, our initial starting point. Where am I starting at? Plus t. Now t is going to be like our kind of like our time, where we're going to be at, times our chain delta x, delta y. This is our direction vector, like our slope. Now the t here basically represents our steps, kind of like when you did vectors back in pre-cal or parametrics in pre-cal. Sometimes this is called the parametric form of a line as well. So when we write this, we would get x, y equals, well, my initial starting point. This is my initial starting point right there. My initial starting point, where do we start at? 2, 3 plus t, and now my direction vector, negative 5, 2. And that would be the vector equation of our line. This equation gives all the points x, y that has this initial point from the origin. So very easy to do. Now, what we like about this form is it makes it really easy to convert to what we call the parametric form of a line. We can use the vector equation to get this, and it's really simple. So if I want to write the vector equation of this line right here, it's given by this formula: x equals x1 plus at, y equals y1 plus bt. Now you don't really have to memorize these formulas. All you really have to do is match up everything. Ready? Remember, these are my points, right? And this is my direction vector. So if I match up all the x's, x equals 2 plus negative 5t. I just kind of like distribute the t. That negative 5 is in my x component. So to get y is going to be equal to, y equals 3, that's my y point, plus t, and this negative 2 is my y, so if I like distribute that t, it would be 2t. So it would be plus 2t. And that would be our parametric form of a line. So if you go to part 2, we'll talk a little bit more, see a few more examples of these. I'll see you soon. Bye.